Hey everyone, I'm Alex, and today I'm going to tell you about an open source security graph tool that I work on called Cartography. My talk is called Using Graphs to Improve and Scale Security Decision Making. It's definitely a huge shame that I'm not able to see you here in person today. I'm actually not a Hawaii resident anymore. I live in Seattle now, and I am all kinds of homesick. But anyway, I hope you find the tool that I present today, Cartography, and the techniques useful in your own teams. And I look forward to hearing from you in like feedback and contributions. So I'd like to tell you a little bit about myself. I'm a Hawaii boy. I'm from Makakilo on the west side of Oahu, live in Seattle now. And my homesickness is going to come out in all kinds of ways during this presentation. I'm a software engineer at Lyft Security. I work on all sorts of interesting problems there, and I have a background in red teaming cloud environments. In previous roles, I've worked at NSA, and I've also worked at Microsoft before. Back home, though, no one really asks you about your work, though. See, we care about the important questions, such as, hey, were you in grad? Which basically means, where did you graduate from? And in particular, it's not your college. They're specifically asking for your high school. And we ask this question because you can make all sorts of fun generalizations about who someone is based on what high school they went to. And I went to Iolani, which everyone gives me a hard time for because it's the fancy school. But I got my start doing programming stuff over there. I grew up on the west side of Oahu. This is the view of the hills in the backyard of my childhood home. When I was growing up, the cows would come super, super close. So I don't know if you can see there, there's like a little barbed wire fence. I don't think they do that anymore though. This is a view from one of my favorite spots, Townside, and double rainbows are a very normal occurrence over there. But everybody seems to forget that the traffic is absolutely horrendous. I mean, I know Seattle and the Bay Area and all these other big cities got bad traffic, but I don't know, man. I still think back home, H1 westbound at 5 p.m. on Friday, good luck. But anyway, you didn't come here to hear me talk about how homesick I am. I'd like to tell you a story about how we worked on and built a tool called Cartography in the first place and the problems that it solves. It all began with a common problem that all security teams face. Things are moving too fast. You got to ship. And with all that pressure to ship, what happens is that teams accumulate security and tech debt because there's no time to document anything. There's all sorts of tribal knowledge, and hyper growth leads to a hyper growth in a larger attack surface. And one of the problems that we wanted to ask ourselves was, can we understand, track, and better manage our infra as it changes over time? This is made harder by the fact that modern infra is complicated. Permissions models are complicated. Delegating access to, understanding the question of who has access to what, under what conditions, and it's not straightforward. I'm going to get into this in more details. And how do you authenticate someone? How can you tell if someone is who they say you are? In the cloud, you might have a username and password pair to authenticate somebody, or you might just have, how do you manage things like 2FA? How do you manage things like, you authenticate someone, but then all those other different ways to manage identities. Who can become whom? Do you open yourself up to transitive risks? And I'll get into these scenarios a little bit in detail in my talk. So we want something that can help check and audit our accesses and understand the policy grants that we have on cloud resources. With multiple vendors, lots of ways to configure things, it's pretty easy to get security wrong, and there are huge consequences for getting it wrong. And with that, everyone faces this problem where there's no time, not enough hours left in the day, and not enough money to make it happen. What can we do with these constraints with a small team or even a large team, because everyone's got a constraint? We need to automate whenever practical. We need to aggressively prioritize what we take on as a security team. And I'd like to give credit to my colleague Sasha Faust, who came up with this idea for Cartography by asking a question similar to this, where can we apply an offensive security approach to what are essentially keep the lights on problems. Well, what offensive approach are we talking about here? What am I talking about here? Well, there's this famous quote, and if you've been in InfoSec the past couple of years, you've almost certainly seen this at some point, and that's defenders think in lists, attackers think in graphs. As long as this is true, attackers win. So I'm sorry about the overused Drake meme, but this quote has been cited so much, it's almost become as ubiquitous as the Drake meme. And I promise, I'm bringing it up again for a good reason. John Lambert at Microsoft made this influential paper where he said that quote. And the idea is that if you're only looking at your high valued assets in terms of lists, there's so many other attack paths that you miss out on. If an attacker were to compromise the terminal server in your environment, and they would find ways to dump credentials off that terminal server and then pivot within, I guess this is representing a Windows domain environment, past the hash and move their way closer to that high valued asset, if all sorts of zigzaggy ways. And the same logic applies in the cloud. In fact, it's even more complicated in the cloud because you don't have a single source of truth in an AD environment where like you have your domain controller. And so, yeah, so if you're like us, if you're like us at Lyft, where you're at a company where all your infra is cloud-based, you got your work cut out for you. And so with that kind of thinking, we wanted a self-maintaining map, something that would highlight structural risks and answer these hard-to-answer questions, show these non-obvious connections between assets, identities, and give us something to, give us this visibility into our security posture. Something like this could be used for security research scenarios, red blue teaming, and help make the work of compliance reports and audits a whole lot faster. Existing solutions that we were considering at the time, they were either cost prohibitive or we weren't able to extend them in the way that we wanted. We weren't able to augment them with our own context, the ways that we wanted to make use of their data or extendable. And so to deal with these shortcomings, that's where Cartography comes in. So Cartography is a Python tool that pulls data from multiple sources, including AWS, Google Cloud Platform, all sorts of others, ties them all together by representing all that data in a Neo4j graph database. And we found that this has helped us represent problems. Now I'm going to show you why looking at security problems in a graph in security is useful. First scenario, incident response. Suppose we have a compute instance, it's 3 a.m. at night, and we find out that it has malware running on it. What do we do? Well, if we have our organization modeled in sort of a graph view, then what we're able to do is quickly respond to it by using an approach like this. We want to find out what service does this EC2 instance belong to? Who are the people that are on call for that service? And how can we reach them? What Slack channel do we talk to? What is the team that person is on call for? What code is actually running on that EC2 instance? And then finally, for after action, what is the Jira queue that is associated? And so if you have it represented like this, you have all your graph edges to find out, you have an asset, like what are the ways can we connect one asset to another? And I like to show you how, at Lyft at least, we've modeled our organization as a graph. And so we use an identity provider called Okta, and Okta is, at least the model that I have shown here, is fairly straightforward, where you have a person, that person has an Okta identity and can be granted membership to an Okta group. All of that rolls up to an Okta organization object. Okta and AWS can talk together. You can have an AWS role. You can make it so that if you're a member of an Okta group, you're allowed to assume an AWS role, which is an AWS identity. AWS objects roll up to AWS accounts. Accounts are ways to represent ideas like different departments and the different concerns and for different build units. It's a way for an organization to segment itself. And a human, we also have in here HR data, so we can find out a human, their reporting structure, who are their managers, what teams do they belong to. You can do this with Workday or anything similar where you have a data feed that shows that shows your organizational structure. Humans can also have G Suite data. Humans can also have G Suite identities where we can find out what Chrome extensions are installed on a given employee's laptop, because Chrome extensions, they ask for all sorts of permissions. And then you want to find out the attack surface, like what kind of opportunities that presents to to the fleet of company machines. And so you're kind of getting the idea here where we're starting to have an extensible, pluggable platform. Your graph becomes most useful when you can take our existing modules and join them with your own. And doing so is a straightforward process. I'll go into another scenario here. It's fairly simple where I have an Okta user identity. I am a member of an Okta group called developers, and I am allowed to assume the AWS role called developers because I'm a member of the Okta group. And this role, developers, is part of the dev account on AWS. So far, so good. This is the way that it's meant to be designed. You can set up Okta and AWS to work together in this way. Now, AWS also has another feature where if you are an AWS role, you can assume another role. And there are many reasons why you might want to set this up for convenience. And then, there's many reasons why it's totally fine for a role to assume another role. However, in this case, this role is called auditors for this particular example. And the auditor's role belongs to the finance account. Is it okay for someone in the developers group to be able to assume the auditor's role, which belongs to the finance account? Maybe, maybe not, depending on how your organization works or whatever the compliance rules are. But if you're going through the AWS console and trying to find through different web pages and trying to run different AWS CLI commands, this is not an easy question to really find out. It's a little cumbersome. So having this in a graph, all in one view, is very, very powerful for us to give us that answer about what are these opportunities to cross trust boundaries. Do I have visibility on opportunities to move between privileged identities and protect my assets? So here we got this idea of being able to move across different data providers from Okta to AWS. Once in AWS, cross account boundaries. The architecture to set up Cartography is fairly simple. And the idea is that you simply run a command line sync, you run a command line tool, and it will start one of our intelligence modules. So our plugins, you can write your own plugins. We call them Intel modules. And so the Intel module will pull data from the data source and then write it to the Neo4j graph database, which exposes a web browser endpoint to view stuff, as well as a Bolt endpoint for faster, like if you want to write more Python code to go talk to that endpoint. After that, we run a cleanup job to ensure that your graph only has the most up-to-date data at all times. We also do data enrichment, and I'm going to go into that right now, where at this stage, we've ingested all of our data into the graph. We have a set of nodes. We just made a list of everything, including our compute instances, including our network interface data. We have a decent picture of what our AWS infrastructure looks like. Now let's add some intelligence to it. And we want to answer the question, is my compute instance open to the internet from the perspective of these security group roles? And so from that perspective, we can look at it. I will show you how we answer that question. So we have modeled our graph like this. An EC2 instance has a network interface. which belongs to an EC2 security group, has a number of rules, and those rules may be associated with IP ranges. One of those ranges is the 0.0.0/0 subnet, meaning the open internet. So we can ask a question. Let's draw a path from the internet to an IP rule and see what security groups match that sort of rule. And are there any network interfaces that are associated with that security group, and do they roll up to any EC2 instances? If so, then set a flag on the EC2 instance for exposed internet equals true. So this way, later on down the line, we can just simply query for the EC2 instance and say, give me back all of the compute instances that have exposed internet equals true, and I don't need to understand or remember how this path was derived unless I'm developing the platform. I really want to go and dive in deep in the details. So you have a very quick way of making these inferences in the graph. You can make your own plugins this way, your own analysis jobs. Cool. So the next thing that I would like to show, building on this idea of intelligence, this is an idea that we have built fairly recently in April of this year. Credit to my colleague Andrew Johnson, who built this. And so right here, we wanted to answer this question about how do we find out what identities have access to what resources? Earlier in my presentation, I mentioned that this is a very complicated problem to answer, and we've at least attempted to answer this to I would say, pretty successful extent in AWS. It's not quite all the way there, but then I'm going to show you what I mean. So we want to answer the question of what identities can access what resources, such as storage buckets, compute instances, data clusters. What actions can they perform on these assets? So if we got an AWS principal and identity on an S3 bucket, well, how do we do this? And so right here, the way that AWS represents their permissions is through a mechanism called IAM, Identity and Access Management. And an AWS principal has a policy that applies to it. Every policy has one or more statements. One of those statements could be an action called S3 get object, and it has either allow or deny and a number of other different statements that can determine whether you have access and to what resources. So in cartography, if you look at those kind of tan looking nodes there, you see that we do a little bit of computation on what is connected to what, evaluate those statements offline. And then so if you look in the center there, right by that question mark, we see that, okay, if all of those nodes exist, that get object, if that matches, then we know that we can grant that we have derived the fact that this principal can read from this bucket. And similar logic can be applied to do other things, like finding things like, can you write to an S3 bucket? Can you query from a DynamoDB table? Can you terminate an EC2 instance? This is a fairly extensible way. It's customizable. And, the result looks something like this, where you can see that, you got Andrew, who is able to assume an AWS role. And as that role, you can write and you can read to all of those sensitive S3 buckets. And that's kind of what it looks like in the graph. We have just published a blog post just yesterday on Medium. So check this out. I am whatever you say I am. Andrew came up with the title. I think it's great. So you can go and look that up and find out all the details on how we did that. And I'll talk briefly about what a real-life deployment of cartography looks like. And I'll give credit to our co-maintainer, Marco Lancini, who has written a lot of these ideas in blogs. And he's been able to showcase a lot of the things that you can do with cartography in a real-life environment. You can hook it up to, so one of the problems that you may have noticed when we were going through those prior examples is that learning that Cypher query language can be very complicated. It's very powerful. We're able to do things like derive what EC2 instance nodes are connected to the open internet. Drawing that out is kind of neat. It's fun for a developer, but then if you want an end user who doesn't necessarily have the time to get into that, you want an easy way to present that to them. So you can create Jupyter notebooks that allow them to run a set of reports, and then they can receive that data. He's also demonstrated the idea of being able to surface this data in Elasticsearch and make it consumable with Kibana, which can then lead to Kibana dashboards. And every manager loves dashboards. And then so you can see like tracking changes over time in your infrastructure, all sorts of different reports that you can run. Cartography can be the source of data for all of these ideas. And you can find all of these sources in his blog post, Mapping and Tracking Moving Clouds. So check out marcolancini.it. And so another idea that's kind of neat here, I mentioned tracking changes over time. Another thing that's great with cartography is that we have a feature called drift detection, where if you have, you can track how your graph changes over time. So in this case, if we have a brand new exposed EC2 instance to the internet, we can get an alert in Slack that this is new, that this has happened. If we have a new IAM admin in the graph that we have detected, we'll get an alert in Slack and find out about that, and then it will let us do some investigation on that end. With that, I'd like to talk about other plans that we have coming next, what is in store for cartography and our roadmap, and then kind of this little bit about the dream state, about where we want it to go. There are some things that we know, and kind of incremental changes that we know can really make the graph a whole lot more useful, a whole lot more robust, and that's DAG-based data syncs. We want to make it so that if directed acyclic graph, we want to make our data sync path be more robust, so that if one sync fails, then it doesn't crash the whole sync, and then maybe using something like Airflow, for example. Lots of different ways to fix that problem. We would like a nicer plugin framework. I mentioned earlier that we have the platform already provides some level of extensibility. It's fairly easy to create an Intel module, but we'd like to abstract away a lot of the details so that people are even more willing to make new frameworks and more plugins. And because the graph gets more powerful, the more correlations that you're able to make. We're also exploring the possibilities for near real-time updates. Right now, the process for the graph is a little bit wasteful in the sense that you run the data sync, it grabs all assets, and then if you run this on a cron, that's like every single day, you're getting every single thing as if it was new, right? You're not doing a diff on like what are the assets that were simply new from the last time that you queried it. So there's a lot of repeated work happening there. So if we could have a sync process that would instead consume it from an event stream, such as CloudTrail or some other way. And as always, more data types, we'd like that. And then finally, I put this automated actions section separate because it's a little bit more of a long-term vision that we have. So with automated actions, we've recently pushed to open source in the past week a feature that includes Amazon Elastic Container Repository image scan results. So if you're running Kubernetes and you have a set of images, you store them in ECR, we want to have visibility on what are the risks and CVEs and vulnerabilities that affect Linux packages that are part of those ECR images. So we want to have visibility on these vulnerabilities in our infrastructure, and we want to action upon them. And the way that we were thinking of doing that is being able to get the CVE package of the image and the graph, and be able to create a Jira ticket that references all of those assets. And of course, what's the problem here, right? We make a ticket, and then how are we going to give it enough context so that it's actually useful and not just noise? So where we can find the correlation on what service is that image deployed to. And then from earlier slides I've shared with you, we have a correlation of from what service to team, what is the team that owns that service, who is on call for that team, what is that team's designated Jira queue, what is that, what is the correct key that I can send, to them. And then finally, with all of that context in the data, we're able to get that Jira ticket, give it all that necessary context, assign it to the right person. And so this is just scratching the surface of what we're able to do, where this is just simply tracking your debt, tracking it in, tracking the security issues, and then hopefully leading it to an action. It would to move toward this sort of dream state where you have a set of robots, a robot army in your infrastructure that uses the graph as a sort of map that runs around and fixes problems. It would be fairly straightforward to build a sort of orchestrator that uses the graph as that state a sort of a state machine, and then do those actions and remediate them. With like automated pen testing, you want to do it in house. There's lots and lots of different possibilities for this work. And so with that, I would like to tell you, I would give you a little bit of my own calls to actions here. Please go ahead, play with your own graph. Go check us out at github.com/lift/cartography. Join our community. We have a Slack channel. It's on the Lyft open source software Slack channel. You'll find the link over there in the repo, channel Cartography. We would love to come, and we would love for you to say hi either on Slack or in our monthly video discussion. We have a bunch of meetings where anyone is welcome. And if you have different ideas, we would love to hear them. Let's all work together. Most important from that, tell us how to be useful for you. I'm thrilled to be here at Local Moco Security. Our goal is to grow and improve the project to meet this bar for high quality open source security tools. And with that, thank you very much for having me here. It's again, a shame that we're not over to be there in Maui, but thank you very much, and I'm here ready to take your questions.
All right, thank you very much, Alex. And if you put us on that last photo that you had, I think we both feel in Hawaii at that time. So thank you. But let's go ahead and get into some of the questions because that was a great talk you had there. And the first one there, so it's very easy to see that cartography is an intelligence tool from a graph perspective. But then can you talk a little bit about how your team runs queries there? Like, is it its own query language? Like, is there certain statements that are like built into it? How does that work?
Right. So our main database backend is something called Neo4j, and Neo4j has a query language called Cypher. And Cypher is the main reason why we picked Neo4j, because this query language is very, very intuitive, where you're, as kind of showed in that example earlier, you're able to draw a node and literally draw that path, and we found that very intuitive. The way that we use it internally is either by querying it directly like that, or there's also ways where you can create a process that runs those graph queries and then exposes it to, say, a PostgreSQL table so that it translates it to table form. And then that way people who are more familiar with tables can go ahead and view that table data. And then if you want to integrate those tables with a platform such as, say, Superset, then you could go ahead and do that. And then so you would see like bar charts, graphs, all kinds of great manager catnip, Yeah. There's like ways that we've talked about to make this process more generalizable and open source. And then we've started like different issues on GitHub about how to turn graph into something more friendly. But this is all very much in progress, and these are problems that we're interested in.
Oh, yeah, thank you very much for that. So, next question for you is cartography looks great, adds the graph in there. Obviously, it seems rather that Lyft has a strong handle on maintaining the data sources. Where the individuals' names are, where the AWS piece. Can you talk about what that looks like at Lyft? Like, how do you guys know that the data source is like primed, it's correct, you guys aren't running into any hiccups into what's coming into cartography?
Is the question about data correctness, like making sure that we pull data and then it's correct?
Yes, yeah. So, what I can imagine is that for some companies that don't have a great handle on asset inventory, because that's big thing in terms of like having the right name. People leave companies. People say, "Hey, look, that was old."
Mm.
So, how do you guys have those processes set up
Ah,
to make sure like, what's coming in is correct?
yeah. So to that point, one thing that we do is we always make sure that the graph has the most current state of everything running. The way that we do that is, let's say that we run the sync twice a day, once at like 5 a.m. and the other time at 5 p.m. And then so 5 a.m. sync runs, it like grabs everything, puts in the graph. 5 p.m. sync comes, and then what that does is that it's going to put everything into the graph, and it will delete everything that was in the 5 a.m. sync if it does not exist anymore. Does that kind of make sense? So like we don't get we get rid of all that stale stuff, and things that still exist, we still keep them in the graph. And you can set up a drift detection query to monitor things as those assets are deleted or added into your infrastructure. And we also have like some logic in there to detect things such as if there is an ex-employee, for example.
Okay. And last question here, and then we'll cut to the break. But thank you for sharing like the roadmap and the future of where cartography is going within your own organization. Because I think one of those is getting those actions and automated actions. How do you guys plan to measure like the impact of some of this and say, well, this is the direction that we're going because we've been able to tell a story like this so far? How do you guys measure impact of cartography?
That is a very, very good question. How do you measure impact? And I think that that's something that a lot of security organizations are having a difficult time with. For us, one of our key metrics is tracking what are the number of actions with drift detection that have happened. So one thing that we try to do is like we have a metric that says the number of security actions that have happened as a result of a drift detection finding. And then we kind of triage, like, so we have an alert that says that there is a brand new AWS IAM admin. And so this alert comes in, and then we need to know how to triage it. And then is this alert useful or not? And then so if it is useful and we make an action of it, then we will increment that metric. And then so that kind of tells us, okay, an action was taken that helps make more secure. So we can say that one of the ways that we could tie success metrics to how the security team is doing in general and how we are providing actionable insight for the rest of the company. And I think that that's one thing. But then basically, like in general, oh yeah, we've also had of another metric talking about how many other teams can use the data. So the number of teams other than Lyft Security that have taken a dependency on the graph data, because what that shows us is that it's not just Lyft Security that's making use of this data. With all of the other correlations that I've shown earlier, it's possible for teams like infra or teams like uh, anybody that wants to like tracking things like how much is like how many assets inventory, what is costing. Lets us answer all these questions. What are the other teams at the company, what is at the company that have taken a dependency on me? What are the number of calls that they make against me? And then so with that, you can measure just how useful you are to other places.
All right. Yeah, no, and it's definitely a question that a lot of people in the security industry are asking is like, how do we measure? How do we kind of gauge that? So thank you very much for your responses there. I mean, it sounds like just from what I know in from what you shared today, a lot of great things coming out of Lyft security these days. We look forward to seeing the next evolution of cartography. And thank you very much for joining us here today, Alex. Aloha, and hope you get some island vibes on your own time.
Appreciate it. Thank you very much.